Yes, we are still in carbonyl compounds, and we say these carbonyl compounds, they are split into two. We say we have the ketones and the aldehydes. We don't want to call them like that. Also, we can say the alkenones and the alkanyls. So we are still in alkanyls, and we have seen how we can at least prepare them in the lab. We have also seen the physical properties and the chemical properties. Now we are still in the chemical properties, and we have seen the first part where we said part A was about burning, which we normally call combustions. Then B was that their effects on litmus, could be litmus solution or litmus paper. And we said this one here, when we burn them, when ethanol is burning in presence of oxygen, we shall be in position to form what we call carbon dioxide and water. And we say that is in plenty supply of oxygen. What is the oxygen is limited, we shall be in position to produce carbon monoxide, and at the same time should be formed, which is carbon itself. Then we also say that litmus, this substance has no effect on what? On litmus. So we describe it as neutral because uh, litmus, okay, if it is red, litmus paper will remain red. If it is blue, it will remain blue litmus paper. Now let's see the part C now, which is oxidation of ethanol. So in your senior two, you learn about oxidation, and we said oxidation is simply the addition of oxygen, or we can say oxidation is the removal of electrons, or we can say oxidation is the removal of hydrogen, or we can say oxidation is the increase in the number of oxidation states. So you can define it in two ways, but also can be defined in form of what? In another way, where we said oxidation is simply the what? The removal of oxygens. Then we say the addition of electrons, the addition of hydrogen. Then again, decrease in the number of oxidation states. Now here, when we talk of oxidation, that should be at the back of your mind as the student of chemistry. The four definition on both sides, defined in terms of, I mean, oxidations. I've defined it, but the other opposite is reduction, of course. Now here we are still in oxidation, but then also we shall come to reduction. So when we shall talk about reduction and we talk about oxidation, we are meaning that in oxidation, we are meaning those four things which are occurring. So here you'll be in position to see whether they have added oxygen or they have removed oxygen. So here, when you look at it critical, what is happening here is oxidation, where we say it is the what? Addition of oxygen, at the same time removal of electrons, at the same time removal of hydrogens, or increase in the number of oxidation state. Then the opposite is the reduction that we are going to talk about, where we say the reduction is simply the removal of oxygen, addition of electron, addition of what? Of hydrogen, so substances, then also decrease in what? In oxidation state. So those are the things you should know here. So here, when you get ethanides in presence of this constant, these powerful oxidizing agents in presence of hydrogen ions, so we call it acidified potassium dichromate 6. The color is therefore the color is orange, and if it is reduced now, because in chemistry we said when you are oxidizing, you can also be what? In the process you will be reduced. So this one here, the orange, the color, the original color for this reagent now will turn to green. And that is the observation. So this is the equations. So when I get my ethanides, I will be in position to form what we call ethanoic acid because of this functional group. This is ethanol because you are seeing this functional group or aldehydes. Now let's go to addition reaction. In addition reaction, we are saying these ethanides can undergo addition reaction with hydrogen cyanide to form 2-hydroxypropanone nitride. So this is the product form, and this is the one we have named 2-hydroxypropanonitride. Now this compound which is formed here, it is formed in presence of hydrogen cyanide. So in heavy chemistry, this one here, there's a mechanism where they can come up with, and you'll be in position to see how this reaction is coming about. But the syllabus does not emphasize that. So therefore, we shall just take the reaction in this format where we say, if I get my ethanides in presence of hydrogen cyanide, I'll be in position to form, what we call 2-hydroxypropanonitride. Nitride. So now this is Roman 1. Now how about Roman 2? Addition reaction. We are adding. So ethanol undergo addition reaction when shaken. So that means if this is the test tube and I put my ethanol, of course, and again I put what we call sodium hydrogen sulfide. Sodium hydrogen sulfide. If I put this one also, add it here, then I check it very well vigorously, we shall be in position to produce what we call hydrogen ethyl sodium sulfate. And this is the compound. So what I was talking about here, the mechanism, how this reaction come about, is none of your business for now. You'll be in position to see it ahead of you when you advance with chemistry. And then we have reduction reaction. So here in the reduction, we can say ethanol can undergo reduction with the hydrogen in presence of nickel catalyst. So nickel catalyst, these are transition elements, and one of their characteristics is that they act as catalysts. So they have catalytic property, and nickel is one of them. So that's why you see it here. It is used as a catalyst in presence of hydrogen. And we shall be in position to form what we call the primary alcohol. So if I get my ethanides in presence of nickel catalyst, and this nickel catalyst, you can say nickel cat, we shall be in position to form ethanol. Now, when you come here in polymerization, we said alkanides can be readily converted to a variety of addition polymers, and we said this addition polymers is simply the formation of elements which are unsaturated to form what we call the polymers. Just like alkenes, and the best example of alkenes we are talking about is diethene, which can undergo addition polymerization to give for us what we call the polyethylene. So we are done with that part. Now let's go to test for alkanines. These carbonyl compounds can also be tested in the lab, and we shall be in position to say, because now we don't test for this thing, how will I know that I'm dealing with the OH, which is for alcohols? How will I know that I'm dealing with this, which is for carboxylic acid? How will I know that I'm dealing with this, which is for alkenes? How will I know that I'm dealing with this, which is for alkynes? How will I know that I'm dealing with the functional group, which is like this for the carbonyl compounds we talk about? That's why it is very, very important for us to distinguish between these different functional group. And when we are distinguishing, we are focusing on the functional group. Why? Because that is where the reaction is occurring in the molecule. So the reagent used here is what we call the Brady's reagent. This was a guy called Brady, and he came up with this reagent, and it is called 2,4-dinitrophenyl and it is written like that. Now, we are going to talk about aromatic chemistry, and we shall be in position to see what we call the benzene ring. But before you getting confused completely, let's at least see, let's say something about the benzene ring you have been seeing. So this one you are seeing like this. This one is what we call the benzene. You can call it the benzene ring. Now that's why you have seen it attached to the nitro group, and that is this amine, and then this is the nitro group also. Now this one here can be written in this format also. You can get it like this. I can put it like this, then I put it here, I put it here. So this is the double bond we are showing. Or if I don't want to write like this, or I can now open up the chains and say this thing also can be written like this. I can mean to show the position. This is carbon, this is carbon. This one here is carbon, this one here is carbon, then this one here is carbon, this one here is carbon. Now we have how many carbon atoms? 1, 2, 3, 4, 5, 6. So if I want to show the bonds, so here I'll have double bonds, I'll have single bonds, I'll have double bonds, I'll have single bond, I'll have double bond, I'll have single bonds. So this is exactly this one. Then in the process, we shall now show what we call the hydrogen atom, the hydrogen atom, hydrogen atom, hydrogen atom, hydrogen atom. We're still following the principle that carbon is supposed to have 4 bonds. If I don't want to put it like that, I will say C6H6, which is uncommon. So this is what is here. But the moment you attach it to these other constituents, and a hydrogen atom can be removed like this, and we shall be in position with something like that. Then from here, just like that. Now we shall go and talk about this chemistry ahead, but just for you not to get confused what is taking place here, for you not to see them like they are dot or portals. Now this one is called 2,4-dinitrophenyl hydrazine, and we are saying that, or you can put it in this format. This one is also very correct because this place is what we represented with the ring. Now this is used to take the presence of carbonyl groups. So this is the functional group we are detecting, carbonyl functional group, and this reagent is also orange powder. So you get it in powdered form, but at the same time you will dilute it and use it for testing in the lab. Then now, formation of yellow-orange precipitate to show identification of carbonyl compound. So okay, let me take it to the lab small. If this is your test tube, okay, this is the test tube, I'm in the lab, and I have, let's say I have the compound here, but I don't know compound. Let's say organic compound, and I don't know what functional group is there. But now you're using these reagents. You now get to put it clockwise until it is an excess. Put, let's say, this reagent, 2,4-diphenyl hydrazine. Put it here. Now, if here we have, in this compound, we have this functional group. Here we shall be in position to see whether yellow or orange, depending on the the amount of this reagent. If it is much, you will see this orange precipitate. If it is moderate, you'll be in position to see the yellow precipitate, and you will now conclude as a chemist that I'm dealing with this functional group. Now, what is here is the OH. If it is the OH group, what will happen? What will happen is that you will see nothing, and we call it an observable chain. Whenever I'm dealing with the other functional group, I'll not see anything. So that is why it is specifically for what we call the carbonyl compounds. So these are also work for alkenones the same way. Now this is the equations. If I have, this is ethanyls combined with 2,4-nitrophenyl hydrazines, and this is the yellow precipitate which is being formed at the end of the reaction. The water molecules is being given out. Or you put it like this and you'll be in position to get these compounds, which is the yellow precipitate. Observation, yellow precipitate form. This chemistry is very, very, very simple. It's just a matter of checking. You need to be critical enough on how you can come up with these equations and we call it organic chemistry because we'll be in position to be dealing with these bonds only. So let's meet in the next lesson.